Hi, this lesson is all about some of the other properties that we can use to identify minerals, such as hardness. This image is of a raw diamond, the hardest substance we know of. Now, as geologists, what we mean by hardness is how resistant is it to scratching. So, for example, if I took a hammer to this diamond, I could shatter it into small pieces. That's not what we mean by hardness. So hardness is how well it can resist scratching, which is one of the reasons that diamond is such a good cutting tool. Okay, let's have a look at how we measure this. We use a scale called Mohs scale of hardness, named after an early geologist who devised this scale, and it's a relative scale. So we start at the bottom with talc, which is softer than gypsum, which is softer than calcite, which is softer than fluorite or fluorspar, which is softer than apatite, which is softer than orthoclase feldspar, which is softer than quartz, which is softer than topaz, which is softer than corundum, which is softer than diamond. So this relative scale can be used to measure the hardness of minerals. So typically a mineral might be given a hardness value somewhere on this scale, maybe to 1 decimal place. Now we don't need to measure it that accurately. What we need to be able to do is to establish the relative scale of any minerals we're testing compared to some common everyday items. Let me show you. This is a mineral hardness kit. If we open it up, we can see that we have 9 of the minerals on Mohs scale arranged in order. We have talc, gypsum, calcite, fluorite, apatite, feldspar, quartz, topaz, and finally corundum. There's no diamond in here because a mineral with hardness 10 will scratch everything else. It doesn't help us identify a mineral. Now the way this kit works is that a mineral higher up on Mohs scale than the one you're testing will scratch it. So for example, if I take a topaz and apatite, so an 8 and a 5, I'll be able to scratch the apatite with the topaz, but I won't be able to scratch the topaz with the apatite. That's just powdered apatite. Now mineral hardness test kits are really useful for testing all sorts of different minerals. But as well as using a kit like this, we can also use some common everyday materials. The first of these is a simple fingernail. A fingernail has a hardness of 2.5. So if I take some gypsum out of the kit, I'll be able to scratch that gypsum with my fingernail. But if I take some calcite, hardness of 3, I can't scratch the calcite with my fingernail. The second material we use is this. This is a copper coin. I've chosen an old penny from 1967, but any copper coin before 1992, while it was still made out of copper, will do. Now this has a hardness of 3.5. So if I take calcite and try and scratch the coin, it won't do it. But if I take fluorite with a hardness of 4 and try and scratch the coin, I can scratch it. The final tool we can use is a nail made of steel. A nail has a hardness of 5.5. So a nail will be able to scratch apatite, but won't be able to scratch feldspar. So by testing these minerals with these either everyday objects or the test kits, we can work out the hardness of a mineral quite accurately, and it can be an extremely useful test for identifying minerals. If we actually look at the true hardness of each of these minerals plotted on this graph, we can see that there is a definite progression. The minerals do get harder with each step up Mohs scale. But what's really striking is just how much harder diamond is compared to even corundum. It's incredibly hard material. Hardness isn't the only way we can tell minerals apart. We can also look at the density of minerals. We can work this out by working out, for example, how much 1 cubic centimetre of a mineral would weigh. Displace a mineral sample with water, see what the volume is, weigh the sample, and you'll see, or you'll be able to calculate the difference. You can also work it out, and geologists often do, as what we call relative density. The relative density is its density relative to water. It comes out at the same number, but we don't tend to often bother with units. Let me show you an example of this. Here we have two minerals, the white one and the dark one. These two minerals, as you can see, are about the same volume, about the same size. The one on the right, the white one, is gypsum. So if we take that and we put that on our balance, it weighs just over 80 grams. The darker one is galena. If we weigh that, remember it's about the same volume, that's nearly 390 grams. So those two specimens that are similar in size can be very different mass. That's because of the difference in density. We can also use an acid test. This works for calcite in particular. Let me show you how that works. This is calcite. We can identify it by testing its hardness. It's harder than a fingernail. It's softer than a copper coin. We can also see its rhombohedral cleavage, or even its rhombic crystals. But there's a more reliable way of testing for this mineral. For this, we can use this. This is 0.5 molar hydrochloric acid. And if we take this acid and put a little bit of it onto the mineral, you can see that it fizzes. The acid reacts with the calcium carbonate in the mineral and releases carbon dioxide, which makes the bubbles that we can see coming off the mineral. It's a very distinctive property, and it allows us to reliably identify calcite even when we can't see really good crystals. Okay, our last test is a taste test. This again applies to one mineral in particular. Let me show you how that works. The last of our mineral tests is one that's very distinctive to this particular mineral. This mineral is halite. Now, halite could be white, could be clear, This particular one is sort of an orangey brown colour. It's got a little bit of iron in it. It has cubic crystals, although we can't see any in this. But there is one property of this that is absolutely unique. Oh, it's a really salty taste. This stuff is rock salt. Very distinctive. So licking it, we can see, or we can taste that it's soluble. It'll dissolve in the water on my tongue and give that horrible, nasty, salty taste. It's very, very distinctive for this. Okay, so a taste test can help you with these things, but you need to be careful. We never, ever taste test anything that's metallic. Okay, we've now seen all the different mineral tests that we can use to identify minerals. By choosing carefully the right ones, by applying them accurately, it's possible to identify not just the 10 minerals that you need to know for GCSE, but really any of the thousands of minerals that have been identified by geologists worldwide. Next time, we need to have a look at some of those minerals that are on your GCSE specification. I'll see you then.